In this video, we are going to look at the material and energy balance of iron. The preparation of heat balance must be preceded by a complete calculation of a charge balance sheet for the process. The heat balance involves identifying and quantifying the process and reactions that consume or liberate heat in the blast furnace. The heat balance allows us to estimate the extent of heat loss in the furnace. So in this case, we have some calculation that we need to perform to know the amount of ore, to know the amount of slag we are getting, the metal we are getting, so that we know the heat loss and the heat gain. So we are going to take one practical example, and we use that to understand how we can find the material and energy balance calculation. So this is material calculation. We have the material and energy balance calculation, but in this case, I'm focusing on the material balance calculation. So let's take this question. It said that an iron blast furnace produces a hot metal of the following composition: 94% of iron, 2.2% of silicon, 3.8% of carbon. The composition of the iron ore is 84% of what? Hematite, 9% of what? Silica, 3% of alumina, 4% of moisture. Limestone is charged 500 kilogram per ton of hot metal production. The limestone, 95% of calcium carbonate, 5% of silica. Coke is charged 900 kilogram per ton of hot metal produced. Composition of coke is 84% of what? Carbon, 10% of silica, 3% of alumina, and 3% of moisture. Calculate one, the weight of iron ore used to produce 1 ton of hot metal. And the second one is the weight of the slag produced per ton of metal. So in this case, how do we start with this question? How do we start with the answer? We start the answer by drawing the material balance, right? So in this case, we have a material balance drawing. So we have a table, and this is the material balance. We are going to take our information from the question given to us. So we have the ore, right? In this case, let's start with the ore. We have the ore plus the limestone plus the coke into the blast furnace. It will give us a hot metal, give us what? A slag, and give us some gases, which is called the flue gases: nitrogen gas, carbon dioxide gas. Yes. So in this case, let's go to the ore. With the ore, you come back to the question. They say the composition of the ore is 84% of what? Hematite. So we have 84% of what? Hematite is here. Then we have 9% of what? Silica. We have 9% of silica here. We have 3% of alumina, 3% of alumina, and 4% of moisture. We have 4%, and 4% of moisture. We have 4% of moisture here. Then we go back to the limestone, right? And the limestone is charged 500 kilogram per ton. So for every 1 ton, we need to add 500 kilogram of limestone, and 1 ton is 1,000 kilogram. So for every 1,000 kilogram of hot metal produced, we need to add 500 kilogram of limestone. So we go to limestone, we have that it contains 95% of calcium carbonate, 95% of calcium carbonate, and it has 5% of silica, 5% of silica, and the mass of it is 500 kilogram. Let's go to the coke. With the coke is charged 900 kilogram per ton of hot metal produced. That means that for 1 ton, we have 900 kilogram of what? Coke. So it's 900. The mass of coke is 900. Then we go back to the composition of coke. We have 84% of what? Carbon, 10% of silica, 3% of what? Alumina, and 3% of moisture. So we have it here. Now we go to the hot metal. For the part of the question, they gave us that the hot metal has the following composition: 94% of what? Iron. We have 94% iron. We have 2.2% of what? Silicon, and we have 3.8% of what? Carbon. We have the slag. The slag, nothing was given to us about the slag, and the flue gas, nothing was given to us about the flue. So in this case, they say we should find the weight of iron or used to produce 1 ton of hot metal. The 1 ton is 1,000 kilogram of hot metal. Now, after generating this, you also need to generate your table, which will make your work very easy for you to do. So for your table, we know that we have, for the material balance, we have what? The ore. We have the limestone. And we have the coke. And then we go back to the ore. We have what? The first composition is what? The hematite. Then we move on to what? The silica. And we have alumina. We have moisture. We have calcium carbonate. We have what? Coke carbon. So then we have it like this. You can then put in your what? Composition. For the ore, we have what's the percentage of what? Hematite in the ore. We have 84%. For the limestone, do we have hematite in the limestone? No, it's dash. Okay. Then for the coke, do you have hematite in the coke? The coke is charged. We don't have hematite in the coke. Then we go to the silica. The silica, for the iron ore, we have 9% of it. For the limestone does it have silica? Yeah, it has 5% of silica. And for the coke, it has what? 10% of what? Then we move on to the alumina. For the iron ore, alumina is 3%. Then we move on to the limestone. The limestone, do you have alumina in that? No. So we have dash. And for the coke, we have alumina to be what? 3%. We have 3%. Then we go to moisture. For the iron ore, the moisture is what? 4%. Do you have moisture in the limestone? No, so it's dash. Then for coke, we have moisture to be what? 3%. Then we go back to what? The calcium carbonate. For the calcium carbonate, when you check the iron ore, we don't have any calcium carbonate in the iron ore. But we have calcium carbonate in the limestone, which is 90%. And for the coke, calcium carbonate is not in the coke. Then we move on to the carbon. For the carbon, do you have carbon in the iron ore? Nope. Dash. Do you have carbon in the limestone? We don't have carbon in limestone. Do you have carbon in the coke? Yes, it's 84. So these are all percentages. It's in percentages. So after you've done this, I think it's advisable to bring your percentage. It makes your work very, for understanding sake. Yes. After you are done with this, right, then we can go on, because we have it in a tabular form and it can help us find everything we want to find very easily. So let's tackle question number 1, the weight of iron ore. Note that we are going to balance. We are using balance and material balance to answer these questions, right? So then let's go to the weight of iron ore. So for the weight of iron ore, the weight of iron ore from iron balance, right? So we are going to balance the iron. In this case, we are going to look at the iron in the ore should be equal to the iron in the hot metal, which is the fake iron, right? So this is the first balance. Whenever they ask you to find the weight of the ore, you need to do iron balance or the hematite balance. So it's in 2 ways. Let's go through this. After I'll go through the second one with you. So balancing it, we know that iron ore, Because there's iron in the ore, right? Iron in the ore is equal to the iron in the hot metal. You can see that we have 94% of iron in it. So this is the balancing. What is here should what give you what is here, right? Input must be equal to output. So then you try doing it. So we make W represent the weight of the ore, right? Then we come in times, we are doing what? Ion balance. So we come here, have 84% of what? Hematite, which also include iron. So 84 over 100. Then times, this is, let me explain this. Since you are finding the iron in the hematite, we need to have this equation that for us to find the iron in hematite to be the molar mass of the unknown all over the molar mass of known times the percentage of known. Let me explain this one. So the molar mass of unknown all over the molar mass of known times the percentage of known. So in this case, we want iron. So the iron becomes the unknown. So the molar mass of iron is 112. All over the molar mass of the known, in which is hematite, is 160 times the percentage of what the known, which is 84. I hope you understood that. Is equal to, then we come to the iron in the hot metal. We have 94%. So 94 over 100 times the mass of the hot metal was what? 1 ton, which is what? 1,000. And at the end, we have the weight of the ore to be 1,598.95 kilograms. Please, this is very important, what I showed here, because it's going to be used to apply in all the calculation you're going to do. And I hope you understood it. Now, I told you that we can use two ways, whether you balance it with the hematite or balance with the iron. So let's balance with the hematite. So in that case, we know that the hematite ore is equal to the hematite in the hot metal. So in this case, we know that we use W, the ore W times, when we talk about the hematite in the ore, we have 84 over 100, which is the percentage. So it will be W times 84 over 100 should be equal to, right? Should equal to. Now, let's go to the hot metal. Hot metal, we don't have hematite inside. So for us to find the hematite, it will be the molar mass of what? Unknown, which is 160. All over the molar mass of known, 112, times the percentage of known, which is 94 over 100, times the mass of what? The hot metal, which is 1,000 kilograms. And when you do that correctly, you know that our W or give you the same answer, which is 1598.6 kilograms. So don't be confused. If someone is using iron balance and someone is using the hematite balance, don't be confused. They are all the same. But you need to have this in mind, that the molar mass of unknown over the molar mass of known times the percentage of known to find the mass of what? Unknown. Now let's move on to the second question. The second question is asking us to find the slag. In this case, we should find the weight of slag. Finding the weight of slag, you should be able to identify the slag we have in the system. I get it. And from here, from the balance that we did, we know that we have calcium carbonate. And calcium carbonate, the slag that we generate is calcium oxide. We have silica, which is also a slag, alumina, which is also a slag. And we have another slag, but it's not in this question. MnO, also a slag. We have most slag, depending on the question. So the slag, you must be able to identify the slag. Then we are finding the weight. It means that you are going to do a balance for material balance for the each of the slag. This is 3 slag that we have here. Then in that case, we would sum them up to find it. So then let's go on. For the composition of slag for this question, we have calcium oxide, we have the silica, we have the alumina. So let's do the silica balance, right? For the silica, right? Finding the silica SiO2 balance, we take this. Now we go to the ore. Do you have silica in the ore? We have silica in the ore. Then we go into the limestone. Do you have silica in the limestone? We have silica in the limestone. And we go to the coke. Do you have silica in the coke? We have silica in the coke. And then we go to equal to hot metal. Do you have silica here? We have silicon. That means that we can find silica here using mass of unknown or mass of known and so what? The mass of the hot metal. And we go to the slag. That's what you are finding. You guys know. So the material balance will be what? Silica of ore plus silica of limestone plus silica of coke is equal to what? The silica of the pig iron plus the silica of the slag. This is what you are looking for. So in that case, we go here that you know that for the silica here, you have 9 over 100, 9% of our silica. 9 over 100 times this is the ore, the mass of the ore that we found. The weight of the ore that we found, which is this, is the weight of the ore that we found, which is 159. So when you get this one wrong, it means that your answer will be wrong for the balancing. So be careful. So 9% of what the silica in the ore. So 9 over 100 times the weight of the ore plus when you go to the limestone, we have 5% of it, and to be 5 over 100 times 500, as you know that 500 kilogram per ton, plus the coke is what 10% of silica, so 10 over 100 times 900 is equal to, let's go to the pig iron here. We have 2.2% of what? Silica. And 2.2% of silica, what you do now to be what? We are finding, this is 2.2% of silicon. 2.2% of silicon. And in this case, we want silica, right? We want silica. So what I showed you is that we have the mass of unknown over the mass of known times the percentage of known. So in this case, we have the percentage of known is 2.2%, which is 2.2 over 100. Then times the mass of the pig iron was, the weight of the pig iron was what? 1000, which is 1 ton. Times this is the molar mass of what? Unknown is 60. Molar mass of unknown is 60, which is the silica, over the molar mass of known, which is 28, times the percentage that's been already times already, which is 2% of the, then plus the silica of the slag. So yes, silica and the slag, then you do the calculation, and then when you reduce it, you're going to get, for this, you're going to get 143.387 plus 25 plus 90 equal to 47.12571 plus the silica in the slag, and at the end the silica in the slag will give you 211.7. I hope you understood that. This play a vital role. Please make sure you understand it. Let's move on to the next balance of the slag. We are going to the alumina balance, right? Now we check here the ore. Do you have alumina in the ore? We have 3% of alumina in the ore. Then plus go to the limestone. Do you have alumina in the limestone? No, so we don't have alumina in the limestone. Then we go to the coke. Do you have alumina in the coke? We have 3% of alumina in the coke. We have that. It's equal to, do you have alumina in the hot metal? No, there's no aluminum here. But we have one in the slag. Goes to the slag. So in that case, you have 3% of alumina in the ore times the weight of the ore plus 3% of alumina in the coke times the weight of coke equal to the alumina slag. And at the end, you're going to get 74.95158 the alumina slag. This is a material balance. It's very simple. That you check in the ore, do you have alumina in that? Yes. Plus the coke, we have one, but the limes we don't have one. It's equal to, do you have alumina in the hot metal? No, but we have alumina in. We do. If you look at, we don't have alumina in. So at the end, you are going to get the alumina in the slag to be 74.996. Now let's move on to the calcium oxide balance. For the calcium oxide balance, you know that calcium oxide in the slag is solely from the calcium carbonate. Solely from the calcium carbonate. And in this case, the calcium carbonate is from the limestone. But let's do the normal way. We are doing calcium oxide balance. Let's go to the ore. Do you have calcium oxide in the ore? No. So 0. Plus in the limestone, we have calcium oxide because we have calcium carbonate, which in this case generates to give us, well, when it breaks down from the previous video, when it breaks down, you can get calcium carbonate, right? As a calcium carbonate breaking down to calcium oxide. Are you getting it? And in the coke, do you have calcium oxide in the coke? No. So in that case, we have calcium oxide in a limestone. It's go to the calcium oxide in the slag, or to form a slag. Then we do the material balance. So we go here, we have 95% of calcium carbonate. So in this case, we are going to also use known mass of the molar mass of unknown over the molar mass of known times the percentage of known. So in that case, we know that it's 95, right? So we have 95% of calcium carbonate. So 95 over 100 times the weight of calcium carbonate is 500. And this is the molar mass of what? Unknown. We are finding calcium oxide, right? For calcium oxide, the molar mass is 50 and calcium carbonate is 100. So molar mass of unknown over molar mass of known times the percentage of known. And in that case, we go to what? 1 in the slag. When you do that correctly, you're going to get 200, which will give you the weight of calcium carbonate, the weight of calcium oxide. Then, but I'm pleading with you that what I explain about the molar mass of known over the molar mass, that's the molar mass of unknown over the molar mass of known times the percentage of known. That's the molar mass. That's, let me write it down. So molar mass of unknown over molar mass of known times percentage of what? Known. Let me do how they did the calcium oxide. So the molar mass of unknown is what? Calcium oxide. We have 40 plus 16. That will give you 56. 56 over calcium carbonate total will be 100. I get on it. 10 times the percentage of known is what? 95. So 95. 10 times the weight of the flax, which is the limestone. So 500. That's what they did. It's very simple as that. So important to put this in. So at the end, you finding the total weight, we need to add the flax, the weight of silica plus the weight of calcium oxide. At the end, you are going to get 552.685 kg. You can also go through the view again and the molar mass of, or the molar mass of no times 100%. Thank you very much for watching.